Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the memory management in operating systems. Memory management in general, to run a program, it must be brought into the memory. First one, input queue, the collection of process on the disk that are waiting to be brought into the memory to run the program. Next point, user programs go through the several steps before being run. Third one, address binding. And the definition for the address binding is mapping of instructions and the data from one address to the another address in memory. Next one, three different stages of binding. We have the three different stages. First one, compile time. Second one, load time. Third one is execution time. First one, compile time. Must generate the absolute code if memory location is known in prior. Second one is the load time. Must generate the relocatable code if the memory location is not known under compile time. Third time is the execution time. Need the hardware support for the address maps. Example, the base and the limit registers are comes under the execution time. Next one is main memory. The main memory is the central to the operation of the modern computer. Next point, the main memory is the large array of the words or the bytes ranging in the size from the hundreds of thousands to billions. The main memory is the repository of the rapidly available information shared by the CPU and the input-output devices. Next one, the main memory is the place where the programs and the informations are kept when the processor is effectively utilize them. Next one, main memory is associated with the processor, so moving the instruction and information into and out of the process is extremely fast. Next one, the main memory is also known as the RAM, that is random access memory. This memory is volatile. The RAM loses its data when a power interruption occurs. Here we have the diagrammatic representation of the memory management. The start from the registers and followed by the cache. Third one is the main memory. Fourth one is the electronic disk. Fifth one is the magnetic disk. Next one optical disk, and then magnetic tapes. Here we have, according to the size of the memory devices, we have this one. Next one, memory management require for allocate and deallocate the memory before and after the process executions to keep track of the used memory space by the process. Next one, to minimize the fragmentation issues, and then to proper utilization of a main memory to maintain the data integrity while executing of the process. Here we have the 5 points. Next will be the logical and the physical address space. The logical address space. It is generated by the CPU and also refers to as virtual address. The other name for the logical address will be the virtual addresses. Next one is physical address. Address seen by the memory unit. Next point, logical and the physical addresses are the same in the compile time and the load time address binding schemes. Next, the logical address, that is virtual address and the physical address are differ in the execution time address binding schemes. Next point will be the next main memory management units, that is MMU. It is a hardware device that maps the virtual and the logical addresses to the physical addresses. In this scheme, the relocation register value is added to the logical address generated by the user process. Next one, the user program deals with the logical addresses. It never sees the real physical addresses. The logical addresses ranges from 0 to maximum. Like this, physical addresses ranges from R plus 0 to R plus maximum. That here the R value is the relocation. Next one, dynamic loading. Through this, the routine is not loaded until it is called. Better memory space utilization and unused routine is never loaded. Third one, useful when the large amount of code are needed to handle infrequently occurring cases. Next one, no special support from the operating system is required implemented through the program design. Next one will be the dynamic linking, the linking the postponed until the execution time and particularly used for the libraries. The small pieces of the code called the step used to locate the appropriate memory resistant library routine or the functions. Next, the programs linked before the new library was installed and continued using the older library. Thank you.